Hi, and welcome to Calculus 30 with Miss Verity. Today we're looking at 4.4 slopes of tangent lines at a general point. So in our previous lesson, we had talked about finding slopes of tangent lines at specific points. So for this first question, we can do that. We can find the slope of the tangent line at 0, which we would figure out as 0, at 2, at 3, at -1. If I asked you to do that, you would have to find the slope of the tangent line at 7 different points. That means 7 different equations, and that's not as fun. But you'll notice the pattern. I'm going to give you 30 seconds. You can take your dramatic pause or pause this video and try and see if you can figure it out. Spoiler alert, if you didn't pause the video, our slopes are always 2 times the x coordinate. So the slope at -2, 4 would be -4, and the slope at 525 would be, that would be positive. Silly goose. So it is 2 times every x coordinate. And so with that in mind, we don't want to have to basically, for every single point that exists, find the slope independently or individually. So what we can do instead is we can find the slope at every point on that equation. So what does that look like? So now, yesterday we would have said at, say, 1 and f, or 1 plus h. Oh gosh, let's try that again. So we would have said at 1 and f of 1, and then our second point would have been at 1 plus h and f of 1 plus h. Well, today we are going to say, in general, for point x, and then our second, like our y2 and x2, would be at x plus h and f of x plus h. So whatever that x coordinate is, any of them, we want to be infinitely close. So still using that format where our formula is going to be our slope is the f of x plus h minus f of x all over h. Technically, it would be x plus h minus x, but we've realized now that it's just going to be h. So plugging that in for our specific equation that we're given. So plugging our x plus h in, we'd have x plus h squared minus plugging x in, we just have x squared all over h. So now simplifying, so distributing, we'd have x squared plus 2xh plus h squared minus x squared all over h. Our x squareds are going to cancel out, and we can see there that h is common to both, and just like before, we want to have that common factor of h. So now that we've got that common factor, those h's are going to cancel out, and we are going to take the limit as x approaches 0 in our 2x plus h function. So 2x plus 0 is 2x. And so what this means is the slope of the tangent line to x squared at any point is going to be 2x. So this is our slope. This is our equation. So let's do a few more. So using the definition of slope, so definition of slope would be the y2 minus y1, or now in our fancy case, that is going to be f of x plus h minus f of x all over h. This is what we call the definition of a derivative. So we are going to write the equation of the tangent line. So determine the slope of the tangent line at f of x, and then use that information to find the slope at 1 and 4. So yesterday we would have found at 1, done the math, and we would have also had to do the math. This time we're just going to find the equation for the slope of the tangent line at any point. So remember our second coordinate, we've got f of x plus h minus f of x all over h. So plugging x plus h into our equation, we would have the square root of x plus h minus the square root of x all over h. From our limit strategies, we would recall that we need to multiply by the conjugate. So the square root of x plus h plus the square root of x, and we'd also do that to the denominator. Oops. Yeah, there we go. So when you multiply by the conjugate, whatever you are conjugating, so in this case this, you get a difference of squares. So the first term squared minus the second term squared. And so a square root squared just cancels out. And in our denominator, we would have h and the square root of x plus h plus the square root of x. In our numerator, if we combine like terms, those cancel out, and we are left with h over h over h times the square root of x plus h plus the root of x. Those h's cancel out once more. And now that that's gone, we're going to take the limit as h approaches 0. So 1 over the square root of x plus 0 plus the square root of x, which would leave us when we add radicals. So root of x plus root of x is 2 root of x. So that would be what our slope is. So to answer the question, find the slope at 1. So here's our slope of our equation at any point. Our x-coordinate is 1, so 1 over 2 square root of 1. So that is 1/2. That's what f of 1 is. So our slope of the tangent line at 1 is 1/2. Our slope of the tangent line at 4, 1 over 2 root of 4, is going to be 1/4. So the slope of the tangent line at 4 is 1/4. So write the equation of the tangent line. If I don't specify, you can use whatever equation you want it to be, or like whatever form of linear equation, so general, standard, slope point form, or slope intercept. Again, my favorite is slope point form. We have our point at x is equal to 4. There's our x coordinate. We just need a y coordinate. So our y coordinate, if we plug it into our equation, f of 4 is equal to the square root of 4, so that's 2. Our point is 4, 2. So y minus our y coordinate equals our slope at 4, which we found up here, x minus our x coordinate. Again, if you have a favorite form, choose to do it that way. Our next function, so find the slope of the tangent line at any point, and then find that for f of 0 and f of 2. So slope at any point, again, that's our f of x plus h minus f of x all over h. So plugging every x plus h into our x coordinate, I'm going to use brackets to help us separate. So 3 times x plus h squared minus 2 times x plus h. So that was our y2 minus 3x squared minus 2x all over h. So simplifying, 3 times x squared plus 2xh plus h squared minus 2x plus 2h. I'm going to erase that. Nope, not plus 2h. We're distributing a negative, minus 2h. Minus 3x squared plus 2x, because again, we're also distributing that negative. I guess technically I don't really need the square brackets anymore. All over h. So 3x squared minus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x all over h. So now simplifying, well, 3x squared minus 3x squared is 0. Negative 2x plus 2x is 0. And that looks like that should be okay because every term we have left has an h in it, and that's something we're looking for. So 3h squared minus 6xh minus 2h all over h. Either take out your common factor, or we can just start to reduce our h's. So 3h minus 6x minus 2. If we take the limit as h approaches 0, we would get 3 times 0 minus 6x minus 2. Something tells me I have done something wrong. Oh, that should be a positive. There we go. 6x minus 2. So that is our slope of the tangent line at any point. If we're wanting to find the slopes of those particular lines, we can plug those in here. So for f of 0, our slope at 0 would be 6 times 0 minus 2. Our slope is negative 2. If we wanted to find it, 2, 6 times 2 minus 2, 12 minus 2 is 10. So the slope of the tangent line at 2 is 10. So writing the equation, again, find your favorite point. If I find f of 2, 3 times 2 squared minus 2x, again, times 2. Remember, this is just representing the y-coordinate. So 12 minus 4 is 8. So we have the point 2, 8. It didn't specify what type of equation, so I'm going to pick slope point form. Y minus 8 equals, our slope we found was 10, x minus 2. All right, there we go.